We want to look at how we can determine the gradient of a general function y is equal to x raised to power n, where n is positive integer. And to get this expression, we will use the curve y is equal to x squared and y is equal to x cubed to derive the general formula for getting the gradient of y is equal to x raised to power n. Consider points Q and P on the curve y is equal to x squared. So this is the curve y is equal to x squared. H represents a small change, a very small change. So if x represents a very small change, we have the coordinates of point Q as xy, but y is equal to x squared. It means point Q has coordinates x squared. Q will have coordinates x plus h. So this point will be the point x plus h. And the corresponding y value will be the square of x, which is equal to x plus h squared, giving us the coordinate of point P as x plus h, x plus h squared. Now, from definition of gradient, gradient QP is equal to change in y over change in x. So this is x squared and this is x plus h squared. So the change in y is shown there. It will be x plus h squared minus x squared. While change in x is given by x plus h minus x, which is equivalent to h. So we can expand this expression as x squared plus 2xh plus h squared using binomial expansion minus x squared divided by h. We notice that x squared and x squared will cancel out we remain with 2xh plus h squared over h. Now, as h tends to 0, gradient QP will be equal to (2x). Remember, this can simplify as 2x plus h. So as h tends to 0, gradient QP is equal to 2x plus 0, which is equal to 2x. So that is for the case y is equal to x squared. For y is equal to x cubed, there's a small change h, which gives us the coordinate here as x plus h, and the corresponding coordinate on the y-axis is x plus h cubed, because we have y is equal to x cubed as the equation of the curve. This will be x cubed. So change in y will be x plus h cubed minus x cubed, and change in x will be equivalent to h. Expanding, the upper expression gives us x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed divided by h. Collecting like terms, we get 3x squared h plus 3x h squared plus h cubed divided by h, which simplifies to 3x squared plus 3x h plus h squared. As h tends to 0, the gradient QP is equal to 3x squared. So from above, it is observed as follows, that the gradient function for various functions are, if y is equal to x squared, the derivative of the gradient function is 2x. If y is equal to x cubed, the gradient function or derivative is equal to 3x squared. The same can be shown for y is equal to x raised to power 4, that the gradient function will be 4x cubed. For y is equal to x raised to power 5, the gradient function will be 5x raised to power 4. So we notice that in the 4 examples above, a general formula can be derived for a general function y is equal to x raised to power n. That the gradient function is given by n x n minus 1. So the power reduces by 1 in each case, and the old power becomes the coefficient of x. The power reduces by 1, the old power becomes the coefficient of x. Old power is the coefficient of x as the power reduces by 1. So that gives us the general formula n x n minus 1, where n is a positive integer. This process of obtaining the derivative or gradient function is called differentiation. Symbolized dy over dx, which means y differentiated with respect to x also can be written as y prime the derivative or gradient function of y is equal to x raised to power n is dy over dx is equal to n x raised to n minus 1. So that we can say that using the above examples, y is equal to x squared is differentiated to get dy over dx is equal to 2x. Similarly, y is equal to x cubed is differentiated to get dy over dx is equal to 3x squared, and so on. So differentiation of a function gives us the gradient function or the derivative function, usually represented or symbolized dy over dx. We need to take note that not all the time will we differentiate y with respect to x. It depends on the nature of the function being differentiated. An example: to apply the formula, differentiate or find the derivative function of y is equal to x raised to power 7. So in this case, dy over dx is equal to, the power becomes the coefficient of x, and the power reduces by 1, which gives us 7x raised to power 6. The same can be done to the second example. Dy over dx is equal to x raised to power 9 is equal to 9x, 9 minus 1, which gives us 9x raised to power 8, as being the derivative function of the function y is equal to x raised to power 9.